So, a very good morning to all of you. I hope all of you are doing fine. In today's session, we are going to discuss one another important concept of discrete mathematics is relation. Okay, so today we'll talk about that what exactly a relation is, how we can define a relation, and then if time allow, we also talk about that what are the different types of relation we are having. Okay, so without delay, let us start the discussion. Let me share my screen. Okay, so before a relation, the first thing is that we should know is the Cartesian product of the set. Basically, when we are talking about relation means what? We are relating one data set to another data set, or we can say in terms of set theory, we are having set A and set B, and by using some of the logic, by using some of the rules, we are going to relate the elements of set A with the elements of set B. So a relation is nothing but a kind of a rule, a kind of a mathematical formula, a kind of general rule which relate the individuals or data values or elements of one set or one collection with the another collection. Okay, so we can easily understand it in the simple general language. A relation is a rule or a relation is some mathematical formula or some mathematical logic which connect the elements from set A to elements of set B. It may be from set to set itself, it may be from set A to another set B, or it may be from any two different data set or simple same data set. Okay, so this is what we already or exactly know that what a relation is, as the term says relation. Many times we use in the day-to-day terminology. Okay, when we are related to one individual, we call yes, we are in the relation. Okay, now here the thing is that the important thing is that when we talk about the relation, it is a ordered pair. Huh? It always decide from set 1 to set A, ordered pair. The first element is called as an input and the second element is called as a output. Output. Okay, we'll discuss that in the detail also, but to exactly understand that what we mean by a ordered pair, before that, we must know that what is a Cartesian product of set. So let us try to understand how two sets can be multiplied, also known as the Cartesian products of the set. Let A and B be two non-empty sets, then set of all ordered pair such that A belongs to first set, B belongs to second set is called the Cartesian product of the set. Set of all ordered pair, set of all ordered pair of the form A comma B, where the first elements come from set 1, second elements come from set 2, is called as the Cartesian product. Cartesian means we are talking about two-dimensional x-axis, y-axis kind of scenario. It is denoted by A cross B, and we can say it is defined as A cross B is having element of A comma B, where A is from set A and B is from set B. Do remember this is a ordered pair. Okay, this we called as a ordered pair. Always the first element come from the first collection, the second come from the second collection. On in place of A cross B, if I am talking about B cross A, if I am talking about B cross A, then B cross A will be defined like it will have elements of the form B comma A, where B belongs to B and A belongs to A. Simple collection of ordered pair. And do remember, for every A and B we are supposed to do. This we called as a Cartesian product. For example, Suppose we are having a set A having three elements A, B, C, and a set B having element 1, comma 2. Now we are interested to write A cross B. Then how A cross B looks like? Firstly, distribute this A with every element of B, that is A comma 1, then A comma 2, the first two, then distribute B with 1 and 2, then distribute C with 1 and 2. So these all are the elements of A cross B, or we can say this is how we can define the Cartesian product of two set A and B. Okay, in the same manner, if I am interested to write B cross A, the first element comes from B and the second elements come from A. So B cross A means what? I am distributing 1 comma 2 with the elements A, B and C. So 1 comma A, then 1 comma B, then 1 comma C. Now distribute 2. So 2 comma A, 2 comma B and 2 comma C. This is how we can write A cross B and B cross A, also known as the Cartesian product of the set A and B. Okay, do remember they are ordered pair. So if I am having A comma 1 and 1 comma A, they are not equal. They are not equal. Ordered pair means what? First is always first, second is always second. Like in set theory, order does not matter. A set which is having element 1 comma 2 comma 3 can be written as 1 3 2 2 3 1 3 1 2. So order does not matter in the set representation. But when we are talking about the Cartesian product, it is a ordered pair as already defined in the definition too. Like a ordered pair, collection of all the elements of the form A cross B, A comma B, where A comes from A, B comes from B. But there are some remarks related to this Cartesian product. We can see A cross B and B cross A is not necessarily equal. Like this example, you can say A comma B is having one of the element as A comma 1, but B comma A does not have this element. Remember the definition of equal set? Two sets are said to be equal if they are having the same elements inside it. In Cartesian product also, like Cartesian product is also a set. Multiplication of two set or product of two set, better to say. So we will call them as equal if they are having the same elements. Okay. So they are not necessarily equal unless if I make A and B are the same element. That means if I'm interested to find, suppose that I'm finding B cross B, B cross B. So B cross B means we are supposed to make the pair of 1 comma 2 with 1 comma 2. We are supposed to make the pair of 1 comma 2 to 1 comma 2. Let us see how it looks like. 1 comma 2 pairing with 2 1 comma 2. So means set to set itself. Set to set itself means what? How it looks like. Let me write it. So B is having element 1 comma 2 to 1 comma 2. So write all the ordered pairs. So 1 comma 1 is there, 1 comma 2 is there. So 1 comma 1 and 1 comma 2. Now distribute 2. So 2 comma 1 and 2 comma 2. So 2 comma 1 and 2 comma 2. This is how we can define the Cartesian product from the set B to B itself, also known as B cross B. Okay, in the same manner, we can find A cross A, B cross B, sometime also called as B square. Okay, B square. Now, if two set is there A and B with the cardinality, this is the notation of cardinality. Cardinality means we can call it as the number of elements a set is having. So if there are m elements, A is there having m element, B is there having n element, then the number of elements in A cross B, this is what? The number of elements, the cardinality. Then the number of elements in A cross B will be m cross n. How to like verify this? You can see it. A is having three element in this example. A is having three element A, B, C. B is having 1, 2 element. So that means I supposed to distribute A, like if I draw it like this, A, B, C, and over here it is 1 and 2. This is your set A, this is your set B. We are supposed to distribute these ABC with this 1, 2. So A is having two choices, A, 1, A, 2. So two choices with this one. In the same manner, B is also having two choices. C is also having two choices. So total choices 2 into 2 into 2, which is what? A is having two choices, B is having two choices, C is having two choices. So there are three elements which is having two choice each. So total number of choices 3 times 2, which can also be written as 2 cross 2 cross 2. Not like this. Three element and every element is having two choices. So this is how it should be written as number of choices for A, 2, number of choices for B, 2, number of choices for C, 2. So total choices this or this or this. So this is how we can understand the number of element in A cross B is m into n, which can further be written as number of element A is having into number of elements B is having. It can further be defined as the Cartesian product, the number of elements in A cross B is the number of elements in A into the number of elements in B. This is how we can find the number of elements in the Cartesian product. Moving up once again, like as we define B cross B, in the same manner we can define A cross A, and this is how it will be written. A square is what? Having element of A comma A, such that both of the elements comes from the set A to A. Both of the elements are the part of set A. So student, this is how we can define the Cartesian product. Hope you understand it. This is the basic of relation. It means that if we want to understand that what exactly a relation is, we must know first how the Cartesian product of the set is defined. So this is how we can define the Cartesian product. Now move back with the concept that just I told you that a relation is a collection. A relation is a rule which assign elements of set A to the elements of set B. Means once again it is a ordered pair. A cross B gives you all the ordered pair. Like from this set A to this set B, all the ordered pair is defined in the form of A cross B. So now we can make some relation by defining some rules, by defining some rules. The rules may be like that. For this particular example, I can say ordered pair A comma B belongs to R. Ordered pair A comma B belongs to R if the first element, if the second element is representing its position in the dictionary. What I'm doing or what I'm saying that we defined R as a relation from a set A to B. What is A over here? A, I am taking the set ABC, the same example, and B, I am taking the element 1, 2. So I'm defining the relation R. R stands for relation. R defining I am defining a relation R from a set A to a set B, such that A comma B belongs to R if B is the position of A, B is the position of A in the dictionary, in the alphabet, better to say, in the alphabet, like A, B, C, D, A to Z. So what are the elements that will be the part of your set R? So now R will have the element from this set to this set. So the first element is A comma 1. Will A comma 1 will be in R? Will A comma 1 present in R? The answer is yes. position of A in the dictionary is 1. So it's satisfying the rule. Understood? In the same manner, the second is A comma 2. A comma 2 will not be there because 2 is not the position of A in the dictionary. In the same manner, B comma 1 is not there, but B comma 2 is there. Yes. The 2 is the position of B in the, not dictionary, in the alphabet. Sorry for that. Now C comma 1 is not there, C comma 2 is not there. Yes. So this is what the relation. This is the relation which defining the ordered pair from set A to B following the particular rule that I just mentioned. Okay, so this is what we can say a relation can be defined. Now, if you see A comma 1 and B comma 2, yes, it is there in your R also. Yes, it is there in your R also. Like just see over here. So this is there, A comma 1 and B comma 2. So that's why I'm saying a relation, whatever it have, it always comes from its Cartesian product. It always comes from its Cartesian product. So in simple word, we can say a relation is a subset of A cross B. We can say a relation is always a subset of A cross B. If we are defining it from A to B, if we are defining it from A to B, then it is the subset of its Cartesian product A cross B. That's why it's important to know before relation that what we mean by A cross B or the Cartesian product. Now let us move on to the formal definition of a relation, that what exactly a relation definition is. A relation R from a set A to a set B. A relation R from a set a relation R from a set A to a set B is the collection of all the ordered pair. Once again, highlighting this term ordered pair. Okay? Ordered pair means what? Where order of the identities, identities, or better to say elements, or say the data value matters, which satisfy a particular rule, which satisfy a particular logic, which satisfy a particular mathematical formula, or anything that you want to define. As in the last example, what I take, my logic is what? A comma B belongs to R if B represent the position of A in the alphabet sequence. So that is what I am having the logic to define this relation. So a relation is a ordered pair which satisfy a particular rule. We can consider it as a subset of the Cartesian product. Yes, as already defined, a relation will always be a subset of the Cartesian product. So we can do one thing when finding the elements of a relation. First, write the elements of A cross B. Then out of those pair or those element A cross B is having, choose those which satisfy the rule for R and put them along with R. This can also be mathematical written like this. Now, mathematically, a relation is written like this. A relation R is defined from a set A to B. From a set A to B means what? A gives you input. Input means I can say the first element of ordered pair. B gives you output. Output means the second elements. So a relation can also be related like a machine. A relation can be related a machine. A relation is some machine where some inputs given and some output comes. Inputs comes from your domain or also known as set A. We will give some input to it. Suppose input X is given and this machine convert X to Y. So X comma Y is one of the elements of your R. Second input, suppose I give it at X2. I get output as Y2. So X2 comma Y2 will be the next element of this order, this relation R. There are there are huge number of application a relation is having in general life. For example, if I'm talking about uh, chatbots, chatbots in AI system, so they are developed on the basis of the relation from set A to set B. When I put some particular question, so that input map to some output, then that output will be reflected. Okay, Alexa, Siri, these are few of the examples that a relation is used. Okay, so anything where we are having a data set and we want to relate it with something else by using some of the logic, then we can use the concept of relation. Whenever we are doing programming of some tools, the relation is always use some of the tools as some of the basic and important tools. One another example, like many times what happen, there are some systems, like I'm talking about some education system. Okay, so a system is like when you put the PRN, the CGPA is fetched of the CGPA of the student will be shown on the display. PRN 1, CGPA 7.5. So PRN 1, or we can say the name. So suppose that the name is Aman. I will put the name input Aman, CGPA 7.5. So this is the relation representation. So to develop that programming, what they do, they will paired up, right? All the Cartesian product. And on the basis of this relation, they develop the R. And when some specific input comes, that particular output which is related to that input will be reflected or shown on the display. So this is one of the example. It may be there are many students by the name of Aman. So when you give the name input Aman, many of the output shown 7.5, 6.5, 9.5. Huh? If like single input map to many output. At the same time, to remove the this confusion further, the enhancement can be roll number wise ordered pairing, or we can say PRN wise. Huh? Some roll number assigned to Aman. Aman having roll number 11. So when 11 input is given in roll number column, output, if it is CGPA, it will reflect it. So it may be your roll number to your CGPA. It may be your height and weight. It may be some other kind of relation, some other kind of logical relations. Okay, calculator is developed on these relation. Modern tools, which is based on AI, artificial intelligence, machine learning, or CS-based programming, use the concept of relation and its extension. Its extension means function is also used to develop the programming. Okay, so this is one of the important concept. I'm talking about the relation thing, so try to understand it carefully. And those especially who are from this domain can develop some programming by using this concept also, but as per their need. Okay, moving ahead. So now let us take some example, some mathematical as well as some realistic example I will take. Now I consider a set A having element 1, 2, 3, 4, 5. Set B is having element 5, 6, 7, 8, 9. Now let us try to develop some relation. So suppose I defined a relation from set A to B. So this is your input collection. This is your input collection, and this is what your output collection. Okay. Let the relation is defined. I will take those ordered pair x comma y such that the second one is equal to twice of first plus 3. Twice of first plus 3. Both x and y should be from both x and y should be from x is from set A and y is from set B. Then what will be the elements of R? What kind of elements will be there in R? The second element is twice of the first plus 3. If I'm writing 1 comma 5, just try to understand the Cartesian product 1 comma 5. Can I say this element belongs to your R? That means your y, the second element, should be twice of first plus 3. So can I say 5 equals to twice cross 1 plus 3? Yes, satisfied. So 1 comma 5 will be there in your R. So this ordered pair is satisfying this condition, hence it will be there in your R. In the same manner, we'll list other elements. So let us see what will be there in your R. So these are the three elements in R, which is 1 comma 5, 2 comma 7, and 3 comma 9. Okay, one another way to write it, this is what we are writing it manually. One another way is what we can write A cross B first, write all the elements which are there in A cross B. Like if I try to write it is 1 comma 5, distribute 1 with everything. So 1 comma 5, then 1 comma 6 in the same manner the other element. What will be total number of elements in A cross B? A is having 1, 2, 3, 4, 5. B is having 1, 2, 3, 4, 5. So A cross B will have 25 elements. A cross B will have 25 elements, and out of these 25 elements, choose those ordered pair which satisfy this condition. Y is equals to 2x plus 3. Y is equals to 2x plus 3. So this is how we can define R. So this is the logic, or we can say this is the rule that we define in the definition. A relation R from set A to B is the collection of ordered pair which satisfy a particular rule. So this is what we are talking about, the particular rule. This is the particular rule. This is the particular logic. This is the particular mathematical formula. Okay, let us take a few more example. So suppose that this time, let we are having set A. It is having element, let it be 2, 3, 4, 6. Let we are having set B, having element 1, 3, 4, 5, 6, 7. Or let us just reduce the size of B. So I am taking in B 1, 3, 4, 5. 1, 3, 4, 5 in B. So these are the elements in B and these are the elements in A. Let us define a relation R from set A to set B. From set A to set B. So the first rule I am using, A comma B belongs to R. Let me make it as R if the condition may be anything. You can decide it if X divides Y. If X divides Y. When I'm saying divide, I'm talking about complete divisibility. Okay, the same thing can also be written in place of saying A comma B belongs to R. We can say A is related to B. How to read it? We will read it as A is related to B. A is having relation with B if X divides Y. This vertical line, a straight long vertical line, is known as the divisibility operation. Divisibility, we call this as a divisibility operation, and it means what? X divided by. Do remember, do not make yourself confused. This is X upon Y. No. This is what? This means what? X divides Y. X divides Y. That means it is Y upon X. We can say Y upon X gives you some integer. Understood? This is what we mean. Like 2 divides 4. So we can write 2 divides 4, yes. But we can't say 4 divides 2. So this is how it is written, not divide. 2 upon 4 means 4 upon 2 equal to 2 integer. But when I'm talking about 2 upon 4, it is not an integer, so not divisible. Okay, so be careful with this relation. Many times we use this. So the relation is what we defined as A comma B belongs to R if X divide Y. So what will be the elements there in your R? So two ways. The first way you can write A cross B first. Write A cross B first. And from A cross B, whatever pair satisfying this condition, we can take it out. Or simply by using common sense, We will list all those elements which satisfying the condition. So let us try to write the elements in R. The first element is 2 comma 1. Can I say 2 divides 1? No. So 2 comma 1 is not there. Second element is 2 comma 3. 2 divides 3? No. So it should not be there. The third element is 2 comma 4. 2 divide 4? Yes. So it will be there. In the same manner, 2 comma 5. 2 does not divide 5, so I will not take 2 comma 5. So that means when I give the input 2 to a machine which is programmed like this, I will get the output 4. If this is the input and output collection. In the same manner, talking for 3, 3 divides 1, no. 3 divides 3, yes. Every number divide itself, so 3 comma 3 will be there in your R. 3 comma 4, no, it does not divide 4. 3 comma 5, no, it does not divide 5. In the same manner, let us pair it with 4 2 6. 4 1, not there. 4 3, not there. 4 4, yes, it will be there. 4 4. 4 5, not there because 4 does not divide 5. 6. 6 does not divide any of these elements. So this is the collection of your R. So your relation R is having these three pairs only. This is one of the thing I did it manually. Another way you can write the Cartesian product like 2 comma 1 is there, then 2 comma 3, then 2 comma 4, then 2 comma 5, in the same manner 3 comma 1, then 3 comma 3, then 3 comma 4, then 3 comma 5, in the same manner for 4. So 4 comma 1 is there, 4 comma 3 is there, 4 comma 4 is there, then 4 comma 5 is there. In the same manner, 6. So 6 comma 1, then 6 comma 3 is there, then 6 comma 4 is there, then 6 comma 5 is there. This is your A cross B. Now, out of this A cross B, what we are supposed to choose? Those ordered pair which satisfy the given condition. So we'll choose those ordered pair which satisfy the given condition. So this is not there. 2 comma 1. It will be there in your R. The answer is no. This is not there. 2 comma 4, yes. This is not, yes. So simply this is how you can do cross and take and write all those pairs which satisfy the condition. So these are the three pairs which satisfy the given condition. The same can be represented in terms of set notation or graphically. So this is your set A having element, this is your 2, this is your 3, then 4, then 6. The same manner, set B is having element 1, then 3, then 4, then 5. Now connected. So 2 comma 4 is there, yes. So 2 comma 4 should be there. 3 comma 3 is there, yes. So it should be there. 4 comma 4 is there, yes. It should be there. So these are the three relations we are having from the data set A to data set B, which satisfying the operation of divisibility, which satisfying the operation of divisibility. Okay, let us define one more relation, second part. So this time I am saying A comma B belongs to R1. I am giving the name as R1. And what is R1? Defined from set A to B in the same manner. Okay, A comma B belongs to R1 if A equals to B. Then what will be the elements inside R1? We are supposed to write those ordered pair in which the first element is same as the second element. So let us see, is there any choice? 2 1 is not there, 2 3, 2 4, 2 5, 3 1. Yes, 3 3 is there. Then 3 3 I will write it in your R1. Is there any other element? Yes, 4 4 is also there. So do write 4 4 in your R1. No other choices, no other choices there. So this is what your R1 is all about. Only these two pairs are there. Okay, we can define some more relation. We can define some more relation like this time, taking one more third part. I'm saying R is a relation from A to B, and A comma B belongs to your R2 if I can take it as LCM. LCM of A comma B, let us take it as 6. So those ordered pair whose LCM is 6, that will be there in R2. And R2 is what? R2 once again defined from set A to B. Same as the last one. So what will be there inside R2? So move back and see which pair is having LCM as 6. LCM of 2 and 4 is not 6. 2, 5 not 6, 3, 1 not 6, 3, 3, 3, 4, 3, 5, 4, 1, 4, 3, 4, 4, 4, 5, 6, 1, 6, 3. Yes. This pair, 6, 1, LCM is 6, 6, 3 is 6. So 6, 1, LCM of 6, comma 1 is 6. 6, comma 3 is 6. Is there any choice whose LCM is 6? So let us see. 2 comma 3 is also there, na? I missed 2 comma 3. 2, 4. Yes, 2 comma 3. LCM of 2 comma 3 is also 6. So that will also be there in your R. So these are the ordered pair whose LCM is 6 and they belongs to your R. Understand? So this is how we can define any logic, any rule, any mathematical formula and listed the elements. And listed the element. It is not always that we are having relation from A to B. It may be from anywhere to anywhere. It may be from anywhere to anywhere. Let us write one more example. So this time I am defining a relation that A comma B belongs to R if we can see A and B is having uh, a common factor 2, a common factor 2. I'm writing just them randomly, so you can also define it. So those ordered pair which having a common factor 2, that means they are having 2 as a common divisor. What are the elements in your R? What are those ordered pair in which both A and B is divisible by 2? Both A and B is having one common factor which is 2. So move back and let us see. So 2, 1 is not there, 2, 3 is not there. Yes, 2, comma 4 will be there because 2 and 4 both is having common factor as 2. 2 divides both of the things. In the same manner, let us see 3, 4, 3, 5, 4, 1, 4, 3, 4, 4. Yes, 4, 4 is also having 2 as a common factor. Then 4, 5, 6, 1, 6, 3, 6, comma 4 will also be there because 6, comma 4 is also having 2 as a common factor. So this is how we define this relation R2. In place of writing the notation belongs to, like I can say 2 comma 4 belongs to your R2. The same can also be written as 2 is related to 4. 2 is related to 4. 2 is related to 4. What is our common factors? So 2 and 4 is having common factor as 2. So both notation widely used for representing the elements of a relation, and this is how we can define the relation. I hope you understand the concept of Cartesian product as well as a relation, that how we can define. We can take some real life example. For example, we are having two collections of straight lines. A comma B belongs to R if A is parallel to B. So list all those ordered pair which is having both the line parallel to each other. In place of parallel, we can say they are intersecting each other, intersecting at a right angle. We are having collection of all the triangles. Set A is from A to itself, A to A. And A is a collection of triangle. A comma B belongs to R. If both the triangle is having at least one angle as let it be 60 degree. So many situation is there, many kind of logic is there which can be used to define a relation. Okay, so that's all for this session. Probably in the next session, we'll talk about the different types of relation.